So students, in continuation of our lecture on this image-based generative models, the next architecture which we'll see now is the Generative Adversarial Networks, GANs. So they are somewhat different when you compare with the VAE or AE. They are called as adversarial models. So what adversarial models mean is that they always have a competitor. So like in games, so in video games, what we do is we will be having two players. So one player will try to match or outperform the second player. So those type of things are called as adversarial tradings. They are actually used in many artificial intelligence models. So that architecture is used in this generative adversarial networks. So where the generative adversarial networks are used are they are used in image based defect identification things. So in those domains, you need very high quality images, and also there is only limited data set available on those images. So what you have to do is with the limited data set, you have to create synthetic images in such a way that they can be used for training other models. So for those things, we can use the generative adversarial network model. So as I said, where generative these things can be used is for defect data creation, enhancing the vision system training, and reducing inspection errors. So what is the architecture of the generative adversarial network? So it has two components. So like in the autoencoder and variational autoencoder, there were two things. One was encoder and decoder. Here you are having two setup like generator and discriminator. So generator is the creative part and discriminator is the criticizing part. Imagine like your movie review system. So what happens is that when a movie is released, some critics try to give a review of the movie. Based on the review, we go for the movie. It depends upon the choice of the user. So same thing here. What happens is the generator is like a movie creator. It creates some image. So what the discriminator does is it compares it with the original image. So as we can see in this structure, the original image, this will be compared with the generated image. If they match perfectly, then it will be approved by the discriminator. They don't match, then it will be rejected by the discriminator. So based on the rejection of the discriminator, how much loss is incurred, that loss will be back propagated to the generator and its weights will be updated, and the process will continue till the generator generates the uh, image which is close to the actual image. So this is the training process. So multiple images will be given. What the generator will do is it will try to recreate an image which is closer to the original image. So if it is successful, then the training happens. So based on this, the training completes. So once the training is completed, then the need for discriminator is eliminated. So we will discard the discriminator and we will use the generator to generate images. So that is the overview of this GAN. So as you see here, generator will produce image. It will be classified as real or fake by the discriminator. So this will give you a better idea. So generator will generate the image. It will be processed to discriminator, which will have the both real and the fake image. So it will compare both and it will give its feedback to the generator. So the process of updating the weights happens through backpropagation, gradient descent, etc. So where this can be used. So this can be used to produce realistic outputs. So compared to the other two models, GAN can produce realistic models and balanced learning. So generator and discriminator both complement each other and balanced learning happens. So common challenges with the generative model is that it is a mode collapse happens. So what happens is that generator will try to oversmart the discriminator. So like the students trying to fool us, students trying to outsmart us, what these discriminators will do, generator will do is it will try it and figure out a pattern which can be given to the discriminator again and again to fool it. So if it generator learns a specific pattern which is accepted by the discriminator, then every time it will repeat the pattern again and again. What happens? The learning stops happening. So that process is called as mode collapse. Training instability. So if the discriminator is too powerful, then whatever the model, whatever the output the generator is producing, it will be rejected by the discriminator. So many issues like this can happen. Overcoming these issues and creating a stable training can result in beautiful data set like this. So synthetic data sets which can be used to train the model for detecting defect-based images automatically. So without human intervention, when you train an AI model, then the model will be used to predict whether the given image is defect or defect-free. So that's the beauty of these generative AI models. I hope this lecture was useful to students. Thank you. We'll see you in the next lecture.